All right, today we're going to do something a little different, a little fun. We're going to travel back in time to solve a physics problem that uses some really weird Old English units of measurement. It's going to be a blast.
And hey, a special welcome to everyone tuning in from the Step by Step Physics YouTube channel. So glad you're here. We're going to break this one down together.
So where's this challenge coming from? It's a true classic. We're tackling problem number 2 from the very first chapter of Halliday and Resnick's Fundamentals of Physics, the 12th edition. It's an awesome problem for really mastering unit conversions.
Okay, so here's our puzzle. The book introduces us to these wild-sounding units, the gray, the line, and the point. Our mission, should we choose to accept it, is to convert an area of 0.50 square grays into square points. I know, it sounds like something from a fantasy novel, but the method we're about to use is pure, beautiful physics.
First things first, we can't solve a thing until we know what we're even talking about. So step 1 is to crack the code on these units. Let's figure out what they actually mean. This little table is basically our decoder ring. The problem tells us that a line is 1/12 of an inch. A point is 1/72 of an inch, and the real key here, a gray, is 1/10 of a line. See how they're all connected? That's what we're going to use.
So let's connect those dots. If 1 gray is 1/10 of a line, and 1 line is 1/12 of an inch, well, we just multiply them together, right? 1/10 times 1/12 gives us 1/120th. So there it is. 1 gray is equal to 1/120th of an inch. That is the key that unlocks this whole thing.
All right, so we have our definitions, but here comes the twist. And this is the part of the problem where a lot of people get tripped up. We're not just converting a length. The question is about area. That's a whole different ballgame.
And this brings up the most important question for this problem. How do you actually convert an area? You can't just use the same conversion factor you'd use for a simple length. There's a trick to it.
And here's the golden rule. You got to remember this. To convert an area, you have to square the length conversion factor. Think about it. To go from meters to centimeters, you multiply by 100. But for square meters to square centimeters, you have to multiply by 100 squared. It's that exact same logic we're going to use here.
Okay, we've got our definitions, we've got our strategy. Now it's time to put it all together and build what physicists call a conversion chain. It's a super slick way to make sure your units work out perfectly every single time.
Whoa, okay, I know that looks like a lot, but trust me, it's super logical. We start with our given value, 0.50 grins squared. Then we multiply by our first conversion factor to get from grins to inches. But look, the whole fraction is squared. That's the key. Then we do the same thing to go from inches to points, and we square that one too. And here's the beautiful, almost magical part of this method. Just watch the units. The gray squared on top cancels with the gray squared on the bottom. Boom! Then the inch squared that we just created on top cancels with the inch squared on the bottom of the next fraction. Boom! And what are we left with? Points squared. It's a perfect self-checking system.
So, you punch all of that into your calculator. 0.50 times 72 squared divided by 120 squared, and you get this nice, clean number, 0.18. But hang on, we're not quite done. In physics, we always have to think about precision.
And that brings us to the grand finale. Let's put all the pieces together and figure out the final, properly formatted answer to our little puzzle.
Okay, this part is absolutely crucial. The problem gave us the number 0.50. See that 0 at the end? It's not just there to look pretty. It's telling us that our measurement has 2 significant figures of precision. That means our final answer has to respect that and also have exactly 2 significant figures.
And luckily for us, the number our calculator gave us was 0.18. That's 2 significant figures. It's already perfect. No extra rounding needed this time.
Which means we can now state our final answer with total confidence. An area of 0.50 square grays is equal to 0.18 square points. We did it. We took these totally obscure units, applied the rules, and solved the puzzle. Pretty cool, huh?
Solving a problem like this really makes you think, doesn't it? Our modern system of units feels so permanent, but this is a great reminder that people used to have a completely different language for measurement. It kind of leaves you wondering what other weird lost units might be hiding out there in old books. Thanks for geeking out with me on this one.